So when you are asked to transform a function graphically, you need to start with having some type of table. So we have this function that's graphed for us, and we don't really have an equation, so there's no input-outputness that I can do, but I can create a table and manipulate it. So we're going to take that function and apply these transformations. The first one affecting the inputs is -5, so that's a manipulation of right 5. Then outside the function, we're going up 2. So I'm going to do each of them separately as far as a graph for this. To do that, I'm going to take these coordinates and write them into a table. So I can see a coordinate here at -5, -1. And then just look for other coordinates on the graph. So like -4, -4, there's a point. We see another point down here at -3, -5. Another point at -2, -4. -1, -1. Then we don't see enough, we can do 0, 2, 1, 3, 2, 2, and 3, -1. So the more points you list, the more exact your graph is going to be. If you don't need to list as many points to make your graph still connect and look correct, that's fine. But what we're going to do is move these x values. So we're going to take each of the x values and move right 5, which is actually adding 5 to the x's. So if I moved -5, right 5, that'd be at 0. -4, right 5 is going to be 1. -3, right 5 is 2. 3, 4, 5, 6, 7, 8. So each of those x's move to the right. The y values we're not changing yet. So those y values stay the same. And we would create a graph of each one of those. So 0, -1, 1, -4, 2, -5, 3, -4, 4, -1, and 5, 2, 6, 3, 7, 2, and 8, -1. When we graph and kind of connect and see what happens, it should be maintaining that general shape. So all that happened was this graph moved to the right 5 right now. I want to move it again up 2. So I'm going to take the y values and go up 2, which means I'm going to add 2 to them. The x values are staying the same. So -1 plus 2 is now +1. -4 plus 2 is -2. -5 plus 2 is -3. Back to -2. +1. 2 plus 2 is 4. 3 plus 2 is 5. 2 plus 2 is 4. And -1 plus 2 is 1. This creates our final transformation. So I'm going to go 0, 1. 1, -2, 2, -3, 3, -2, and 4, 1, 5, 4, 6, 5, and 7, 4, 8, 1. The whole thing should still have the same shape. So we had that wiggle, it stayed the same, it moved right 5 and then up 2. With a transformation like this, Left and right, up and down, just those two transformations you can kind of put together. When we start applying vertical stretches or shrinks or reflections, the order really does matter. So if we looked at number 2, the first transformation is affecting the x values plus 2. That's a left 2 transformation. The negative outside is a reflection. So that reflects over the x-axis. It's affecting the outputs. And you would still create a table. All right, let me switch colors so this table looks a little bit different and they don't blend together. But if I put this point, this end point is -6, +6. This is just a line, so you can find each individual point on there, or if you can find the beginning and ending, 0, 3, that's also fine. The more points you put, the more precise it's going to be. Then I can see this next part of the thing goes, let's do that point there, 1, 0. Then it goes all the way down to 3, -6. It changes again to, last point is at 5, -3. So that is the table that we're manipulating. We're going to go left 2. Left 2 is affecting our x values, and moving left shifts backwards 2. So I'm going to take these x's and subtract 2 from them. -6 minus 2 is going to go -8. 0 minus 2 is -2. 1 minus 2, -1. 3 minus 2 is 1. And 5 minus 2 is 3. The y values are not changing, so it's still going to be 6, 3, 0, -6, -3. We can graph that specific transformation. So -8, +6, -2, 3. And that's that whole line that was initially here. So that just moved backwards too. Then we went to -1, 0. We had 1, -6. This was the steeper middle section. And then 3, -3 gave us the last section. If I reflect over the x-axis, that's affecting our y values. So the x's are going to stay the same, but our y values are reflecting, which is multiplied by -1. We can see that reflection there. So the x values stay -8, -2, -1, +1, 3, but the y values have been multiplied by -1. So -6, -3, 0 times -1 stays the same, 0. -6 times -1 is +6 and +3. When I graph this, -8, -6 to 2, -2, -3, this line that was decreasing reflected over the x-axis. So we're folding it down here, which is now increasing. Then we went to -1, 0, 1, 6. So that was that other steep part of the graph. It's reflected, so it's now increasing. And then we went to 3, 3. 1, 2, 3. 1, 2, 3. So it looks like that. So this is our finished version with both all the transformations applied to it. If you were asked to graph this whole thing, you might not have multiple graphs, and that's okay. You don't have to. You can graph on top of this, but you can create all the tables for it. So I would go through each transformation creating your table, and then if you only graph the final version, that's fine. All right, for this one, we have several transformations. So if I go from the inputs and then go to the outputs, first we had a negative x. That negative x was a reflection over the y-axis. So, well, let's list them all first. Then we multiplied by 2. That multiplying by 2 is a vertical, since it's outside of the function, a vertical stretch by a factor of 2. And lastly, we have this plus 3. So lastly, up 3. So this is going to be my final graph once I get there. We have an XY table we're going to create. This first point is at -3, 2. And I can find all the points on there. I can go to this next one here, which is at -1, -4. It stays flat for a while, so all the way up until 2, -4. You can add more detail in here, like 0, -4 is a point, 1, -4 is a point. Then we do this semicircle. So that point at 2, -4 starts the semicircle, then it goes to 4, -2, and back down to the ending point of 6, -4. If I reflect over the y-axis, this is affecting our x values. Our x's are being multiplied by a -1. So I'm going to take this xy table and multiply the x's by -1. So that becomes a +3, a +1, a -2, -4, and a -6. The y values didn't change, so 2, -4, -4, -2, -4. If I graph these, 3, 2 is now over here. So that point has been reflected over the y-axis at 3, 2. 1, -4 is backwards here. That's that initial line that was going on. It has been reflected over the y-axis. Then we went to -2, -4, that flat part. 4, -4, -2 starts the semicircle, and -6, -4 is the end, so that semicircle went like that. If I do a vertical stretch by a factor of 2, I'm now going to be affecting our y values. So those y values have been multiplied by 2. So 2 times 2 is 4. -4 times 2 is -8. Stays -8. -2 times 2 is -4. And -4 times 2 is -8 again. So we graph those. 3, 4. 1, -8. -2, -8. And -4, -4. Then we end at -6, -8. So that was the semicircle that has been stretched. We had our flat section and we had our line. That graph, you can see, has been vertically pulled and stretched by a factor of 2. Then we move up 3. So the x values are not changing, but we're going to move all the y values up 3. 4 plus 3 is 7. -8 plus 3 is -5. Negative 4 plus 3 is at negative 1, and we're back to negative 5. So I graph those 3, 7, 1, negative 5, negative 2, negative 5, negative 4, negative 1, and 6, negative 5. We still have that semicircle that has been stretched. Then we have this flat section, and our line has been stretched as well. So overall, the order in which you did those transformations really did matter, giving this our final version. So this is the final version of it.